drives. Okay. I'll do the numerical problems. Okay. Okay, already studied, you know, the gear drives. Gear drive is a power transmission device. We're having one is driving gear and another one is driven gear. Okay, so and driving gear consisting of a tooth structure. Okay, and one tooth of driving gear meshes with the driven gear when they comes in contact with each other. Okay, so I'll directly go to the problems on gear drives. Okay, so before solving the problem you should know some formula. Okay, first one is velocity ratio. Okay, so this is the diagram, velocity ratio. How to find out the velocity ratio? Okay, so there are two gears, one is the driver gear and one is the driven gear. So d1 is the pitch circle diameter of driving gear and d2 is the pitch circle diameter of the driven gear, and t1 is the number of teeth on driving gear, t2 is the number of teeth on driven gear, and n1 is speed of driving gear and n2 is the speed of the driven gear. So these are the parameters. Okay, and here the linear speed of gear must be same as that of the driven gear. Okay, so the linear speed, okay, you see the diagram. There are two gear drives. One is a driving gear and driven gear. D1 is pitch circle diameter of the driving gear and D2 is a pitch circle diameter of the driven gear. T1 is the number of teeth on driving gear and T2 is the number of teeth on driven gear. And N1 is the speed of driving gear and N2 is the speed of the driven gear. Okay, assuming that there is no slip happens between driving gear and driven gear, the linear speed of driving gear is equals to the linear speed of the driven gear, that is pi d1 n1 equals to pi d2 n2. Okay, and pi the term gets cancelled, so we'll get d1 n1 equals to d2 n2. Okay, and hence n2 by n1 is d1 by d2, that is speed of driven gear divided by speed of driver gear equals to the diameter of driver and divided by diameter of the driven. So speed is always inversely proportional to the diameter. Okay, as the diameter increases, speed decreases. On the other hand, if the diameter decreases, speed increases, and vice versa. Okay, so remember this is a formula, n2 by n1 equals to d1 by d2. Okay, suppose we are going to express in terms of teeth, number of teeth. Okay, so this is a relationship, pi d1 divided by t1 equals to pi d2 divided by t2, or d1 divided by t2 equals to t1 by t2. The speed and diameter are inversely proportional. On the other hand, d1 by d2 equals to t1 by t2 means the diameter is directly proportional to the number of teeth. Okay, and inversely proportional to the speed. Okay, so we can write n2 by n1 equals to d1 by d2 equals to t1 by t2. So this is the equation, n2 by n1 equals to d1 by d2 equals to t1 by t2, where n2 by n1 is called as velocity ratio or speed ratio or transmission ratio. Remember, n2 by n1 equals to d1 by d2, that is equals to t1 by d2. Okay, and next important is gear train. Okay, as I said, gear train is the we are having more than one gears. In normal gears we are having two gears, that is one is driver gear and one is a driven gear. Suppose if the center distance is large, in that case we are going to use the intermediate gears. Okay, intermediate gears are also called as the idler gears. You remember this kind of arrangement is used when the center distance between driver gear and driven gear is more. Okay, so now we are going to find out the velocity ratio for the simple gear train. Simple gear train, you see driver gear is rotating in clockwise direction Okay, gear 2 is in opposite direction, so that, and gear 2 drives gear 3, and gear 3 drives the gear 4. This is the arrangement of simple gear train with intermediate gears. We are having two intermediate gears. Okay, then next we are going to apply the velocity ratio. uh, N1 is speed of gear 1, N2 is the speed of gear 2, N3 is the speed of gear 3, and N4 is the speed of gear 4. Now I am going to apply the speed ratio for gear 1 and gear 2. That is N2 by N1 equals to T1 by T2. As I said, the speed ratio is inversely proportional to number of teeth. N2 by N1 equals to T1 by T2. Similarly, now I am taking gear 2 and gear 3 because gear 2 drives gear 3. I can write N2 by N3 equals to, or N3 by N2 equals to T2 by T3, because the speed and teeth are inversely proportional. So N3 by N2 equals to T2 by T3. Now gear 3 drives gear 4. I can write the equation as N4 divided by N3 equals to T3 divided by T4. You remember, the speed and diameter of inversely proportional, diameter and teeth are directly proportional, and speed and teeth are inversely proportional. We can write N2 by N1 equals to D1 by D2, or it is also equals to T1 by T2. Now for applying the speed ratio between gears 1 and 2, we can write N2 by N1 equals to T1 by T2, and gear 2 drives gear 3, we can write N3 by N2 equals to T2 by T3, and gear 3 drives gear 4, we can write N4 divided by N3 equals to T3 divided by T4. Okay, now in order to get the velocity ratio for the simple gear train, we are going to multiply equation number 1, 2 and 3. So equation number 1 is N2 by N1 into N3 by N2 into N4 by N3, that is equals to T1 by T2 into T2 by T3 into T3 divided by T4. Now here in this equation, N2 N2 get cancelled, N3 N3 get cancelled, we'll get N4 by N1 equals to T1 divided by T4. Now in this arrangement, so N4 is speed of last gear and N1 is speed of first gear equals to T1 divided by T4. T1 is number of teeth on the first gear and T4 is the number of teeth on the last gear. So we can get the equation as N4 by N1 equals to T1 by T4. Okay, hence speed of uh, last gear is nothing but driven gear divided by speed of first gear, that is nothing but driver gear, equals to the number of teeth on the driver gear divided by number of teeth on the driven gear. Okay, so this is the equation for simple gear train. Next, velocity ratio for compound gear train. Okay, remember this is called as compound gear train. Okay, compound gear train means a single gears. Okay, we are having more than one gear in a single shaft. You see in the previous diagram, simple gear train, all the gears are independently arranged. But in the compound gear train, two or more gears are arranged in the common shaft. Okay, you see the diagram, first diagram. So we are having the driver, that is gear 1. Okay, and gear shaft B, we are having the two compound gears. Compound gear means the same shaft holding two or more gears. Okay, so shaft A rotates in clockwise direction, shaft B rotates in anti-clockwise direction. So here inner one is gear 2 and outer one is gear 3, and last gear is there, that is called as driven gear. So in this arrangement we can call gear 1 as driver gear, uh, gear 4 as driven gear, and gears 2 and 3 are compound gears, and they are mounted on the same shaft. Okay, so here gear 1 is mounted on shaft A, whatever diagram you are seeing, it is shaft A, and gears 2 and gears 3 are mounted on the same shaft. On the other hand, this 4 is independently mounted on shaft C. Okay, this shaft C. So this is the front view and this is the top view, already studied in the CAD. Okay, front view and top view. Compound gear train means a single shaft holding two or more gear arrangement. Okay, in this diagram, the gear 1 rotates gears 2 and 3, and gear 2 and 3 rotates gear C. Okay, so gear 1 is driver gear, gear 4 is driven gear, and gears 2 and 3 are our compound gears. So this arrangement. Next, our aim is to find out the velocity ratio of compound gear train. Okay. So first you see the arrangement. Gear 1 drives gears 2 and 3 both. Okay. And then gear 3 drives the gear 4. Okay, it's like that. Now we are going to apply the equation. Gear 1 drives gear 2. We can write the equation as N2 by N1 equals to T1 by T2. And next, we are going to apply the equation between 3 and 4. Okay, now we are going to apply the equation between 1 and 2 over, that is N2 by N1 equals to T1 by T2. Next, uh, we are applying the equation between gears 3 and 4. Okay, gears 3 and 4 is N4 by N3 equals to T3 by T4. Okay, this is the last gear. Now, in order to find out the velocity ratio, we are going to multiply equation number 1 and 2. Okay, so gear 1 drives gear 2. That's why I'm writing N2 by N1 equals to T1 by T2. Similarly, gear 3 drives gear 4. We can write N4 by N3 equals to T3 by T4. In order to find out the velocity ratio of the gear train, we are going to multiply equation number 1 and 2. So N2 by N1 into N3 by N4 equals to T1 by T2 into T3 by T4. Here in this equation, okay, N2 and N3 are same because they are compound gears and they are rotating at the same speed. So we are going to cancel N2 and N3. So in this equation, N2 and N3 are same because they rotate at same speed. Okay. And here the number of teeth vary. We are not going to cancel this term. So in the LHS, we are going to cancel N1 and N2 and N3 because the gears 2 and 3 are the compound gears. Gears 2 and 3 are compound gears. Hence, we are going to cancel the speed of gear 2 and speed of gear 3 are same. So, we are getting N4 by N1 equals to T1 into T3 divided by T2 into T4. Okay. So, we can write in a term like speed of last gear. Speed of last gear means speed of the driven gear divided by N1 is the speed of first gear equals to T1 into T3. So T1 into T3 means T1 is our driver gear and T3 is also driver gear because this gear 3 drives gear 4 and gear 2 drives gear 1. Okay, so it is a product of T1 and T3 and divided by T2 and T4. Okay, that is the number of teeth on gears 1 and 3 divided by the number of teeth on the gears 2 and 4. Okay, this is how to find out the velocity ratio. Now I'll discuss the most important is the numerical problems related to the gear drives. Okay. First problem is the velocity ratio of gear drive is 2. Driving gear has 16 teeth and runs at 120 revolutions per minute. Find the revolution per minute and the number of teeth on the driven wheel. Okay, before that, first you write the given data, driver gear and driven gear. There are two gears in the gears, common normal gear drive, driver gear and driven gear. The number of teeth on the driver wheel is 16 and N1 is 120 RPM. Okay, driven gear having T2. T2 we are going to find out and N2 also we don't know, but they have given the velocity ratio as 2, that is N2 by N1 equals to 2. From this one, we are going to calculate the number of teeth as well as the speed of the driven gear. We know that the speed ratio is inversely proportional to number of teeth. First, you write that equation N2 by N1 equals to T1 by T2. N2 by N1 speed ratio is given 2. Number of teeth on the driver wheel is 16. T2 is unknown thing. So, we are getting T2 as 8 teeth. You see, driver has 16 and driven has 8 teeth. Okay. Next, we got the value of T2. But how to find out N2? Once again, the same equation you have to use. N2 by N1 equals to T1 by T2. Okay, N2 by N1 equals to T1 by T2. N2 is unknown thing. N1 is 120 RPM given in the problem. T1 is 16 given in the problem, and T2, number of teeth on the driven wheel, is 8. So by using this equation, we are going to find out N2 as 240 RPM. Okay, so this is a very simple problem. You remember the equation, N2 by N1 equals to D1 by D2 equals to T1 by T2. Either you can use diameter or you can use the number of teeth. In this problem, diameter is not given. Directly they have given the number of teeth. So N2 by N1 equals to T1 by T2, and speed ratio is nothing but N2 by N1. By using this equation, first we are finding out the number of teeth, and then after that we are going to find out the speed of the driven wheel. This is a very simple problem. Next, we are going to find out one intermediate gear, or it is also called as the idler gear. Okay, a simple gear train consisting of 3 gears. The number of teeth on driving gear is 60, that is T1 is 60. And the idler gear or intermediate gears, the number of teeth on idler gear is 40. And on the driven gear, that is T3, is 80. Okay. If the driving gear rotates at 1200 RPM, means N1 is 1200 RPM, find the speed of driven gear, that is N3, we are going to calculate. And also we are going to calculate the velocity ratio and the sketch the arrangement of the gear drive. Okay, before that, first we have to write the sketch of the gear drive. Sketch of the gear drive is, first is driving gear, and according to the number of teeth you have to draw the diagram. Okay, first circle is 60, second circle is 40, and then third circle is 80, like that. According to the number of teeth, you can increase or decrease the diameter of the circle. This is just a rough sketch. Okay. So given data is T1 is 60, that is the number of teeth on the driving gear is 60. N1 is 1200 RPM. T2, the number of idler teeth on the idler gear is 640. The number of teeth on driven gear, that is T3, is 80. Our aim is to find out the speed of driven gear, means N3 we are going to find out, and also the velocity ratio we are going to calculate, and sketch the arrangement of gear drive. So what you are saying, it is the sketching the arrangement of gear drive. Okay. Next, how to find out the velocity ratio? Okay, directly you can take the last gears, that is N3 by N1 equals to T1 by T3. That is the speed ratio. Always last two first. You have to take N3 by N1 equals to T1 by T3. So N3 by N1 equals to T1 by T3. N3 we don't know. N1 is 1200, T1 is 60, and T3 is 80. So velocity ratio is N3 by N1 equals to 900. Okay, N3 by N1 equals to N3 unknown thing. N1 is 1200 RPM. T1 is number of teeth on the driver gear, and T3 is number of teeth on the driven. All the things are given. Our aim is to find out only velocity ratio, N3 by N1. N3 by N1 equals to you can find out 3 by 4. We are getting the velocity ratio as 3 by 4. Okay, N3 divided by N1 is 1200 equals to T1 is 60 divided by 80. Or N3, first we are going to calculate N3. By using this formula, we are going to calculate 900, because it's 60 into 1200 divided by 80. We are calculating N3 as 900 RPM. And N3 by N1 is, N3 is 900 we got, and N1 is given in the problem. So velocity ratio is 3:4. Okay, that is 3 by 4. Okay. Next problem. Okay. A simple gear train consisting of 4 gears having 30, 40, 50, and 60 teeth respectively. Determine the speed and direction of rotation of the last gear. That is the driven gear if the first gear makes 600 rpm in the clockwise direction. Okay, this direction is also important. If the gear 1 drives in clockwise direction, then gear 2 drives in anti-clockwise direction. And if it is in ACW and gear 3 is in clockwise direction, like that you have to show the direction. And they are in increasing order because number of teeth on first gear is 30, second gear is 40, and third gear is 50, and last gear is 60. So in the increasing order you have to show the circles. Okay, and also the arrangement clockwise, and clearly given in the problem the first gear rotates in clockwise direction. Subsequently you have to draw the direction for the remaining gear drives. One is in clockwise, another one is anti-clockwise, and third one is clockwise, and fourth one is anti-clockwise direction. Okay, this is the arrangement of gear drives. Next, what is the given, what we have to find out is determine the speed and direction of last gear. Okay, direction is in anti-clockwise direction, but how to find out the speed? For that one you have to apply the velocity ratio equation. Velocity ratio is speed of the last gear divided by speed of first gear equals to T1 by T4, because the speed ratio is inversely proportional to the number of teeth, that is N4 by N1 equals to T1 divided by T4. Hence N4 we have to find out. N1 is given in the problem, that is 600, T1 is 30, and T4 is 60. So just you substitute the value. N4 divided by N1 is 600, 30 number of teeth on the first gear is 630, and number of teeth on last gear is 60. So by calculating we are getting the N4, that is the speed of last gear is in anti-clockwise direction, and magnitude is 300 rpm. Okay, this is how to calculate the speed of the last gear. Okay, you see the next diagram. This is a simple gear train. As I said, simple gear train. Okay, so we are having the two or more gears in between the two gears. One is driver gear and one is the driven gear. A simple gear train of wheels consisting of 4 gears A, B, C, D having 20, 40, 60 and 70 teeth respectively. Gear is mounted on a driving shaft, means it is a driver gear. Number of teeth is 20. Okay, next B is intermediate gear, and the number of teeth on second gear is 40. And third gear is C. Number of teeth on the third gear is 60. And last one is number of teeth on the last gear is 70. Okay, so one is in clockwise direction, another one is anti-clockwise direction, and third one is clockwise direction, and fourth one is in anti-clockwise direction. Like that you have to draw the diagrams. Okay, now we have to consider the gears A and B. As I said, the speed ratio is inversely proportional to the number of teeth. So first you take two gears A and B. Then how to write the equation? NB divided by NA equals to TA divided by TB. Suppose you are taking B and C, you have to write NC divided by NB equals to TB by TC. Suppose you are taking C and D, you have to write ND divided by NC equals to TC divided by TD. Remember, speed is inversely proportional to number of teeth. First, I am considering the gears A and B. Gear A drives gear B. So you can write the velocity ratio equation as NB by NA equals to TA by TB, or NB unknown thing, and NA is 500 given in the problem. Okay, and TA is number of teeth on gear drive A, and divided by TB is number of teeth on the drive B. Okay, so we are getting NB as 250 rpm in anti-clockwise direction. Okay, first one is A in clockwise direction and B is in anti-clockwise direction, and magnitude is 250 rpm. Okay, next we have to find out the velocity of second gear, velocity of third gear, that is NC divided by NB equals to TB by TC. NC we don't know, NB we calculated it as 250 rpm, TB is number of teeth on B divided by number of teeth on C is 60. So by using this formula, we are going to find out the NC as around 167 RPM in clockwise direction, third gear drive. And then last gear drive, okay, we have to find out what is the speed of the last gear. Okay, same way you have to use the equation nd by nc equals to tc by td. Okay, nd we don't know, nc we calculated it as 167, tc is number of teeth on the c drive, that is 60 divided by td is 70. So nd we are calculating as around 142.86 rpm in the anti-clockwise direction. Okay, this is how to calculate. uh, One more they have asked, that is the value of gear train. Okay, value of gear train, one more additional equation is there. You remember train value is given by reciprocal of the speed ratio or velocity ratio. Train value is 1 divided by speed ratio. But what is the speed ratio? Speed ratio is nothing but our nd divided by ne. You see the overall arrangement, we have to take the speed ratio as nd divided by ne. Nd we calculated it as 142.86 divided by na as 500. So you're getting some decimal point. Okay, so 0.285 nd divided by na is 0.285. Okay, and the train value is reciprocal of this speed ratio, that is 1 divided by 0.285, are getting 3.5. Okay, next problem is related to our compound gear train. Compound gear train. Okay, so this till now what we did, that was simple gear train. Okay, now the next problem related to our compound gear train. Okay, a gear train consisting of 4 gears, gear A, gear B and C, and gear D, of 20, 25, 50 and 75. Okay, here gear A is 20, the inner gear is 25 teeth, the outer gear is 50 teeth, and last one is driven gear is 75. So you have to draw the diagram like this. A gear train consisting of 4 gears A, B, C, D of 20, 25, 50 and 75 teeth respectively. Okay, and one more condition is that gear A meshes with gear C and B is a compound gear with the C. So gear B and gear C are compound drive. B meshes with D. You have to show the diagrams in such a way that B and D are meshes with each other. If A has a speed of 300 RPM, what is the speed of gear drive D? Okay, sketch the gear train. Okay, this is first writing the gear train sketch is most important. Okay, then after that we have to write the uh, equation. First one is TA is number of teeth on A, 20, NA is 300 RPM. Okay, TB is 25. Okay, next TC is 50, that is TC, and last one is 75. Okay, next as we said, in case of compound gear train, okay, ND divided by NA equals to TA into TB. Okay, so TA into TB divided by TC into TD. Okay, so you have to write the equation like that. That is product of teeth on driver divided by product of teeth on the driven. Okay, that is the velocity ratio of compound gear train. So ND divided by NA equals to TA into TB divided by TC into TD. Okay, so ND divided by NA is 20 into 25 divided by 50 into 75. Okay, and NA is given, speed of the gear A is 300 RPM. You have to substitute the value. You'll get the speed of the last gear as 40 RPM. You remember, as the diameter increases, speed decreases. So after substituting the value, we're getting the speed of the gear D as 40 RPM. Next, compound gear train, another example. Okay. Now I'm discussing problem number 6. This once again compound gear train. Okay, problem number 6. A compound gear train consisting of 4 gears P, Q, R, S having 20 teeth, 40 teeth, 60 teeth, and 80 teeth respectively. Okay. The gear P is key to driving shaft. The gear P is, means it is directly connected to driver shaft, and gear S to the driven shaft. Okay, so in this arrangement, gear P is driving gear and gear S is the driven gear. Q and R are the compound gears. Q and R are the compound gears. Q meshes with P. So you have to show the diagram in such a way that Q meshes with P and R meshes with the S. Okay. If P rotates at 150 RPM, so if that is NP is 150 RPM, what is the RPM of gear S? Show the gear arrangement. So you should be very careful in drawing the compound gear train. So you have to draw the circle in increasing order, and you have to show Q and R as the compound gears. Gear P meshes with Q. On the other hand, the outer gear R meshes with the gear S. First, you have to draw the compound gear train arrangement. Okay, next given values are TP is 20, NP is 150 RPM, that is are the given data. TQ is 40, TR 60, and TS is 80. Our aim is to find out what is speed of the last gear. Okay, so what is the formula? So you have to write NS divided by NP equals to TP into TR. Next Q into S. So that is the product of teeth on driver gear divided by product of teeth on the driven gear. Okay. So NS divided by NP equals to TP into TR divided by TQ into TS. NS divided by NP equals to TP into TR. So in this diagram, TP and TR are the driver gear, okay, and TQ and TS are driven gear. So you have to substitute the value. So NS we don't know, NP is 150 RPM, so equals to TP is 20 into TR is 60 divided by 40 into 80. So we are getting the speed of last gear as 56.25 RPM. Okay. So last problem I'll discuss. This one is related to once again compound gear train. So you see the values properly. So in this problem, diagram is given. From the diagram, so you have to find out the required thing. Illustrated in the figure below is the gear drive arrangement used in the machine tool. A motor drives the gear A at 950 RPM. So means and they are given the number of teeth. Okay, A, B, C, D. They are in increasing order. A is 20, B is 50. That outer one. C is 25, D is 75, E is 25, and F is 65. So based upon that one, they have given the arrangement. Okay. So from this diagram, we are going to find out. Okay, here there are two compound gears. Gear A is driver gear. Gear F is driven gear. The C and B are compound gears. Even E and D are also the compound gear. Okay. So according to our formula, that is speed of the last gear divided by speed of the first gear equals to the product of teeth on the driver gear divided by product of teeth on the driven gear. So you have to analyze. So here T uh, A is driver. Okay. Next, C is also a driver because it drives the D. C, A, C, and E. You see the diagram properly. A is driver gear, C is driver gear, and E is the driver gear. And remaining gears are driven gears. That is B, D, and F are driven gear. Okay, so you see the arrangement in this diagram. Gears A, C, and E are driver gears. B, D, and F are driven gears. So according to the formula, uh, NF divided by NE, that is speed of the last gear divided by speed of the first gear equals to the number of teeth on the driver gear, that is TA into TC into TE divided by TF into TD into TB. So analyze the diagram. A, C and E are driver gear because they drives the other gears. Okay. On the other hand, the gears B, T and F are driven gears. So according to the formula, NF divided by NA equals to the product of teeth on driver, that is NA, NC into NE, sorry, TA into TC into TE divided by TB into TD into TF. Okay, so all the things are given except NF. Okay, so NF divided by NA equals to NF divided by NA is 950 RPM equals to TA is 20, TC is 25, TE is also 25. All the things they are given in the data. So just you take the data and you have to substitute. So NF divided by NA equals to TA TC into TE divided by TB into TD into TF. That is, or NF divided by 950 equals to 20 into 25 into 25 divided by 50 into 75 into 75. So you will get the last speed as 48.7 RPM. Okay. So you remember simple gear train is the one which is having two or more middle gears or intermediate gears or idle gears in between, and on the other hand we are having the compound gear train. Compound gear train means two or more gears, they are connected to a common shaft. Okay, and you have to write remember the equation, very simple equation, that is speed of the last gear equals to speed of the last gear divided by speed of first gear equals to number of teeth on first gear and number of teeth on the last gear. Always you have to take last with first. Okay, and two important things you should remember, that is speed ratio is inversely proportional to the diameter and also the inversely proportional to teeth, that is n2 by n1 equals to t2 by t1 equals to d2 by d1. Okay, this is how to solve the numerical problems in gear drives. Okay, the just I'll discuss so what are the different gear drives used in the things. Okay, so you can just I'll go through what are the different gear drives. Okay, see the structure. First one is spur gear. Okay, spur gear is mainly used to transmit the motion between two parallel shafts. Okay, so when the shafts are parallel in nature, spur gears are used. Okay, and this is the nature of spur gears, and these gears are widely used in the automobiles. Okay, you remember all the gear drives whatever used in the automobiles are of spur gear drive. And second one is bevel gear. So here whenever it's required to transmit the power between two intersecting shaft, one is driving shaft and one is driven shaft, in that case we are going to use the bevel gear. Okay, spur gears are mainly used to transmit the power between two parallel shaft. Bevel gears are mainly used to transmit the power between two intersecting shaft. And third one is our helical gears. Helical gears are mainly used to transmit the power between two parallel or non-parallel. So it is possible to transmit the power between two parallel and non-parallel, but non-intersecting shaft. It is not possible to transmit the power between intersecting shaft in case of the helical gears. Okay, mainly used to transmit the power between uh, non-parallel or parallel, but non-intersecting shaft. And worm gears and worm wheel. Okay, worm gears and worm wheel, we are having one is a wheel which is rotating on the shaft, that is called as worm. Okay, so this is see the diagram. So that is the tooth of worm wheel comes in contact with the worm screw. In that case the power transmission takes place. Okay, and last one is the rack and pinion. Okay, rack and pinion, you see we are having one is rack. Okay, and pinion is a gear teeth cut on it along its periphery, and one is the rack. Here in the rack the teeth is cut along the straight line. Okay, so when this gear rotates, it drives, so that it comes and contacts with the rack, so it moves. and thereby power transmission takes place. What we are seeing in the diagram is the rack and this is the pinion. So when the power transmission takes place, that is the one tooth of rack comes in contact with the pinion. Okay. And advantage and disadvantage of gear drives. Okay. So gear drives are mainly used to transmit the power between parallel, non-parallel, intersecting and non-intersecting shaft. On the other hand, the belt drives are only used to transmit the power between the parallel shaft. Okay. Next, gear drives are preferred mainly over the belt drive because the center distance between the shaft is small. Okay, it is not possible whenever center distance between two drives is small. In that case, it is very difficult to transmit the power between two shafts by means of belt drive. In that case, we prefer the gear drives. The gear drives most efficient when the center distance between two shafts are small, and gear drives are highest power transmission ratio, and they can be used for slow, medium or high power transmission. Okay, and disadvantage, whenever the center distance is too large, in that case they are not suitable. Okay, and here belt drives are not require lubrication, but this gear drives require lubrication because the one tooth comes in contact with the other tooth. Okay, cost for production of gear drives is high. On the other hand, cost for production of belt drive is low. Okay. Now I'm going to last one. I'm going to make the comparison between belt drives and gear drives. Okay, belt drives so are most useful when the center distance between the two shafts is large. So gear drives are most efficient when the center distance between two shafts is small. Okay. Next, belt drives are used only when the power transmission between two parallel shafts. It's not possible to use for non-intersecting and then non-parallel shaft. We are not using belt drives. On the other hand, the gear drives are widely used for parallel shaft, non-parallel shaft, intersecting shaft, and non-intersecting. For all kind of the power transmission, whatever kind of the shaft it is, gear drives are used. Hence, they are more reliable. Okay. Next, in case of belt drives, always slip happens. So where it is very difficult to maintain the exact velocity ratio. On the other hand, there is no slip takes place in gear drives. Hence, it is possible to achieve the exact velocity ratio. Only moderate power can be transmitted in belt drive, but it can be used for high, medium, and low power transmission in case of gear drive. So we'll get the low power transmission efficiency in case of belt drive. We'll get the higher power transmission efficiency in case of gear drive. Okay, so belt drives are not require lubrication, and gear drives requires the lubrication. Okay, this is all about the gear drives advantage, disadvantages, comparison between belt drives and gear drives, velocity ratio, a speed ratio, and then the numerical problems related to a simple gear train and compound gear train. Okay, now I'll stop the session. Okay. Uh, so you can leave the meeting. Chaya and Sanjana Kadan. Okay, you can leave the meeting. Okay.
Yes, sir.